All right, this will be a practice final exam for Math 1103, those that are taking it, to give you an idea of what problems you might run into. And again, the protocol for doing this is you read it, try it out, and then we'll go over the solution. So we know side A is 5, side B is 12, and we want to find the hypotenuse, which is side C. So for this, we're going to use a squared plus b squared equals c squared. Want to find out what c is, and then we go c equals, take the square root of both sides, so it should look like this, a squared plus b squared. Now we're just going to substitute. A we said was 5, so 5 squared plus 12 squared. Add those together, and they want us to round to the nearest, no, and here the answers are going to come out even, I bet. So let's put that in our calculator and see what we get here. So 25 plus 144 is 169, which is a perfect square, 13, and the person had this correct. All right, now here is a simple substitution. Again, pause the tape, write it down. You want to have a strategy for doing this. So I'm substituting the x is 3. A negative 4 is y, so I put that in a parenthesis. So the combination of this becomes a negative 1 that we're going to square. And then just negative 2 times c, which is 3, negative 6. Negative 1 times negative 1 is a positive 1, so our answer is 5. Okay, here we have a simple equation. I don't think we could have anything easier than this. X, we're going to subtract 2 from both sides, or just transpose that, becomes a negative 2. So our answer is 10. I guess you're going to have some easy ones, or hopefully everyone does. All right, a little bit more challenging, but same principle. We're going to transpose. Again, I would like to keep my variables positive. So on this time, this becomes an 8v. Just transpose that. Now we're going to transpose this, becomes a positive 7. 7 and 9 is 16. Divide both sides by 8. V equals 2. Again, show the work on your blue sheet so you can get partial credit, or better if you get full credit. Now, for something like this, they're giving you a picture of a trapezoid, has this many square meters as its area. The base is 7. Well, I guess that would be C is, I'm sorry, 4. The base is 7 here, yep. What we don't know is the height, H. So in the area we said was 66. So the first thing they want you to do in problems like this is pick out the formula. Well, that one's right here. It's pretty obvious. Now, they then want you to solve this formula for the missing letter H. So let's put that here. A equals 1/2 H, and then in parentheses, B plus C. So the protocol for doing this is to get rid of that fraction. This is all one term. So multiply each side of the equation by 2. So here the 2's cancel out. And I will erase that. Just this part. Okay. So how do I solve now for h? Well, once again, it's h times this. This is a factor. So we can divide out factors. B plus C. B plus C. So now these cancel out. And I'll use my eraser. And that's what they want you to write. H equals 2a over b plus c. Now we'll erase this part here because now we're going to substitute. So it's 2 times 66 over 7 plus 4. So 266 is 130 something. Let me check that here. 132, yes. Divided by 7 plus 4, which is 11. You do this division, and we find that h equals 12. 12 times 11 is 132. And again, check your work. You have plenty of time. Does that seem reasonable? In fact, you could put all these numbers in the formula and see if you end up with 66. And again, show the work. Now again, there's the formula that they're looking for here. H equals 2a over bc. And then you are to substitute and find the height, which is what we showed on the previous slide. And that is 12. Okay, let's move on. Now that question had multi-parts. So we're going to raise this up a little bit. It says find the coordinates to plot a graph. Lines or curve will be drawn once the required points are plotted. Okay, again, this one has the answer showing already, but try it. Here we have a 0, -7. And I guess we have to put these points in. All right, let me just make a little t-chart then. And we said always put a 0 here. And if x is a 0, this is in slope-intercept. Y equals mx plus b. So if x is a 0, this times 0 is 0. So y is a -7. That's where they got this first point over here. All right, now what other value? Well, I'm going to choose a 7 here, because if I have a 7 there, that's going to cancel out. And I go 10 then, that becomes 10 minus 7 is 3. And that was what this person put. And then the points plot and the line forms. Okay. Keeping in mind this is your y-intercept. Now I reviewed this technique many times during the course so far, but there's slope-intercept, and we know the slope, which is a -2/5. Now we want to find out what our new b value, our y-intercept, will be, having this slope and going through this point on the line. So we know that our x is a -1 here, and we know our y here is going to be 3. What we don't know is our new b value. We're going to use that technique of getting rid of fractions. We have 3 terms. going to multiply each term by 5, because here the 5's will cancel out. You have to multiply the b by 5. So this now becomes 15. Now the 5's have canceled out. I have negative 2 times negative 1 is going to be a positive 2 plus 5b. Transpose my 2 to the other side or subtract 2. This gives me, let's see here. I got the right signs? Yes, I do. So this is 13, and this is where the other person messed up a little bit, because I see they had this one incorrect. So it's 5b. Now you're going to divide both sides by 5, and you get b equals 13/5. Now you want to write the equation in slope-intercept form. Well, it's going to be y equals a negative 2/5 x, and your new b value now is 13/5, and that's the correct answer. Here they were off, but again they were close, so I gave them 1 point of partial credit because they had the slope right. Okay. Now for this set of equations, they're asking us just to determine if the lines are parallel, if they are perpendicular, or if neither. Now, what would be the strategy for doing something like this? We had said that solve it for the letter y. Put it in slope-intercept. Where you would compare your b value and your m value, your slope and your y-intercepts. And we had said once you solved each of these equations for y, and let me show you, that if your slopes were the same, but the y-intercepts were different, the lines would be parallel. All right, and then we said if you multiplied the slopes together and the product was a negative one, such as 1/3 times a negative 3/1, the negative reciprocal of the other slope, the lines were perpendicular. And that upside down T was to indicate that. All the others were either. Neither, I should say. So we compared the slopes. This one's -2. This one's a -1/2. So the slopes are different. Yeah, but one looks like the reciprocal of the other. So if I multiply them, a -1/2 times a -2/1, I get a +1. So that doesn't meet this definition. So they're definitely not perpendicular. They're not parallel, they're not perpendicular, they are neither. This was the little tricky part because you might be easily led. But again, if I saw that you had solved each of the equations for y, I can give you partial credit. All right, let's go on. Now, for solving inequalities, we said it was the very same as it was for solving equations except for one thing. And I'll solve it that way to show you. So I'm going to add 2z to this side, where this becomes a negative then 2z. Now I'm going to subtract 2, or transpose that. I'm going to keep my inequality sign like that, and then subtracting 2 from that, I get a -6. So you could transpose or whatever method. Now, to solve for a positive z, I have to divide by a -2. Now, anytime you're going to divide by a negative, to keep it true, you have to reverse the direction of the inequality sign. That's the one difference. So this is going to be a positive z is greater then a positive 3. Ah. Now, again, they're going to ask you to graph this later, so let's make a graph. 3 is the number we're interested in. To indicate only greater or lesser, we use a parenthesis, and if it's greater, it faces toward the right, and darken this line if we're sketching it, and then our book uses an ellipsis here, that you're going to have to show later. But they want this in interval notation. So if you have the graph, it's parenthesis, 3, comma, and then the end of this line is positive infinity. And infinity always has a parenthesis. And this person had it correct. Now to select the graph, you have to pick out the right combination here, which is a parenthesis and a parenthesis, which is this one. And then, these form, and you have to just drag it to a positive 3, and then drag this one to the end of the line where the ellipsis will form. So again, study, pause as needed. Now for this one, 2 will go into 12 6 times, and we're going to bring the 5 up. It crosses the division bar, it becomes a negative 5. 6 minus 5 is y to the first power, but we don't write the 1. If you do, they're going to take off points. Okay, let's go on. Now here, what do you do first? Well, you're going to raise the 2b to the 4th to the third power. You do this first. So keep in mind there's a 1 there. 2 to the third is 8. b to the 4th to the third power we're multiplying is going to be b to the 12th. And then now we multiply this by 5. 5 times 8 is 40. B to the 12th. All right, not too hard, but you need to follow the rules. Check it out. Now here is a subtraction of binomials. And we said the protocol to try to get these right is you write one line like we did here, and I put the 1 there to help us calculate. And now it's a negative in front of a parenthesis. So what we need to do is change each of these signs. So this is a positive 6x. I'm going to make it a negative 6x squared and put it in the proper column. And this positive 8, I'm going to change the sign, make it a negative 8. And this is where this person went astray. They left it as a positive 8. They only changed the first one. So now when we add these up, this is a negative 5x squares. Remember, the variables never change when we're adding or subtracting, only if you're multiplying. And this is a negative 11. Now they got the first part right. So again, I gave them partial credit for that. Okay, better to get the full credit. Now here you could use any method, but I'll use the FOIL. We're reviewing the first. So 2x times negative 7x is a negative 14x squared. Now my outers are a positive 8x. My inners a negative 14x. And my last will be a positive 8. Now as I group like terms, I'm going to get a negative 14x squared. Here I'm going to get a negative 6x plus 8. Now I know sometimes a lot of you would leave off the negative sign here, have everything else right. Again, I'd give you lots of partial credit. You just messed up on that one sign. Better to get full credit. All right, going on. Now, hopefully you're pausing the tape and seeing, what do I need to do to solve this? Well, we said you write it. And then you take what's in the denominator and put that under each term now. And now from this stage, you simplify. So we're going to subtract 3 from the 4, and we're left with an x. Minus, now 5 doesn't go anywhere, but we can take this 1x from this 3x down here and get x squared. And then here nothing cancels or simplifies, so, and that is the answer. All right, let's go on. Now again, we're looking for the greatest common factor of these 3 items. And you might say 63 is 9 times 7. 81 is 9 times 9. And 18 is 2 times 9. Now there are other ways to do this. So what's your common factor? Well, 9. Greatest common factor. Someone would say we could take a 3 out of each one too, but that wouldn't be the greatest. I'd give you some credit for that, but again, get full credit. All right, let's go on here. Now, again, I see folks getting this incorrect because they're not reading the instructions properly. It says factor each expression by factoring out the common binomial. All right, there's your common binomial. Well, we said when you have something like this, you put that in one parenthesis. That's your common binomial. And then you're ended up with these other two, 7y squared minus 8b. Because if you were going to multiply these, you would take this first term, multiply it by this, that's what we have here. Take this next term, multiply it by this, that's what you have there. And that's the answer. Now notice, they have this over here first, and then this. Doesn't make any difference. All right, now they want us to factor this if we can. And we don't see many that are not factorable. So it's a trinomial. I'll write it big here. So we put 2 sets of parentheses, and we're going to undo the FOIL. Now our first term can only be x and x. Now we're looking for factors of 8 that have a difference of 7. Well, that's going to be an 8 and a 1. And our middle term is positive, so the outers have to be a positive. Your inners a negative, and there is the factorization. Now you could have done it the other way too. That would work either way. All right, let's take a look at this now. And again, what's the strategy? Try it. Pause the tape. Now I see there's a common factor of 5 here, so I'm going to factor out the 5, and I get 4 minus x squared. Now that's worth 1 point. But now we have within the parentheses the difference of perfect squares. that we're going to factor into their conjugates. 2 plus x, 2 minus x. Okay? Now, I should have given this person 1 point here, but because they had partial credit here. Oh, see that? I must have overlooked that. Sometimes when I click next, it goes 2 instead of 1. Okay, I'll go back and give that person some more credit here. So that should be a 1 there, because they had half of it. But this is the full thing. Difference of perfect squares factors into their conjugates. We've stressed that throughout the course so far. Okay, now here's a good one. It's a trinomial in standard form equal to 0. So this is a quadratic equation in standard form. How do we solve it? Well, we need to factor the left side. And this is a perfect square trinomial, so it'll factor into x. Square root of 25 is 5 and 5. And to get our middle term, the sign comes right from there. So since both of these are the same, and in this next step, they want you to show the factoring of this equal to 0. Because this is already in standard form. It says factor. So that's what they've done. Now, when we solve it, we equal each of these to 0. And we're going to have x equals 5 for one, and x equals 5 for the other. That's on the next slide. And let's just do that here. And since they're both the same, we only use it once. Okay. We're getting toward the end. There's 25 questions on this final. Here they want you to solve each equation for y, put it in slope-intercept form, and pause it and see if you can do that. And hopefully you have something like this. So I'm going to transpose the 2x, becomes a negative 2x, then divide everything by 2. I get this for one equation, which is what this person had. Now you don't put in the 1 there, just a negative sign. And then what I did is I transposed the y to this side, got a positive y. Transposed the 40 to this side, got a negative 40. And then rewrote it in this form. And again, there's a 1x there, but you don't put the 1. So you would leave that blank. And then in this box, a negative 40. Now, when you graph them, and they're going to show you what the graph is, they're going to intersect, as you'll see on the next slide, at 45 for the x value and 5 for the y value. Let's show you that here. Oh, well, they're not showing us that. Oh, I know, it was hidden there. Yeah, I had to scroll down, and there it is. 45, comma, for the x, and then up 5 for the y. All right. All right, now when we look at these, we see that if we divide this top equation by 7, each term by 7, we get x plus y equals a negative 3. Now, if we divide this equation by 8, we get x plus y equals a negative 3. Now, if this side said 8x plus 8y equals a negative 21, that these two would be exactly the same and something different over here, the lines would be parallel. But here, these two lines are not the same. But again, they're saying substitution. You could do that. But basically, you're solving and simplifying these equations and then using inspection to determine that they're the same lines. And that's dependent. If you did something and you ended up with 3 equals 0, that's not true. Those would be inconsistent. And then consistent, you end up with a single ordered pair for x and y. And again, we're reviewing as we do these. Now, I see we did some of these in Chapter 8 where they gave you the word problem but not the equation. Here they're actually giving you the equation. And they want you to solve it using the method of addition. But again, you could use substitution because you have what x is. So let me set this up. You try it. See what you can get. So as not to have too much work here, to be distracting, I'm going to take my y, move it to the other side where it becomes a negative y. And that's my first equation. And I put a 1 there for calculation purposes. And then I multiplied everything here by 100. I got a 7x, a 4y, and I added 2 zeros there. So these are my two equations, and I want something to cancel out. So what would be the obvious thing here? If this were a 4y here, the y's would cancel out. So it already has the negative sign. So I'm going to multiply this equation by 4, and I'll write it underneath. So this is now going to be 4x minus 4y. And then this is going to be, multiply this by 4. So this is going to be 3,200. 4 times 8 is 32, and I added 2 zeros. Now I can use that technique. These will cancel out. This will become an 11x. And now I have to add these up, which I'll do. So we get this. Divide both sides by 11, and we get x is 5,200. And if you subtract 800 from this, you get the 4% is this. So it works out really nicely. Now, for this one, we did one like this already. And c is equal to the square root of the sum of the square of side A and the sum of the square of side B, which was 232. When I take the square root of that, I get this. I look to the fourth position. It's a 5, so I have to drop it, add a 1 to the 1, and make this a 2. So our answer is 15.232. Okay. Let's go on. Our last one. Take a moment, pause, read it over. Now they give us an equation already, so this is actually sort of an easy one. We have x plus 80 equals 102. We're just going to subtract 80 from both sides and get 22. And that wraps it up. Okay, well, it was a little bit long, but hopefully very helpful as we review many of the things we had for our final exam, if you need to take it.